We're asked to use a substitution here. Essentially, this is a hidden quadratic, but we're being guided along the way. So if u is equal to 3x minus 2 in brackets all squared, then u squared will be this thing squared, which will be 3x minus 2 to the power 4. And that means we've got u squared minus 5u plus 4 is equal to 0. And now we've got a quadratic. Let's try to factorize it. It's going to be minus 1 and minus 4. So u equals 1 or 4. Now we're not done. We now need to get it back in terms of x. So it's going to be therefore 3x minus 2 squared is equal to 1 or 4. Right, let's look at these two cases separately. So when 3x minus 2 squared is equal to 1, right, we do not want to kind of expand it. We don't want to expand this out and try to solve a quadratic. This is actually in essentially completed square form, and we can just take the square root. 3x minus 2 is going to equal plus or minus 1. Don't forget to take the negative square root as well on the right-hand side. So 3x, all right, when we have minus 1, it's going to be minus 1 plus 2. We're going to get 1. And when it's plus 1, we're going to get 3. So x is equal to a third or 1. And then when 3x minus 2 squared is equal to 4, same approach again. Take the square root. 3x minus 2 is going to be plus or minus 2. So 3x will equal, when it's minus 2, we'll add 2, we'll get 0. When it's plus 2, we'll add 2, we'll get 4. So x will equal 0 or 4 over 3. Therefore, x is going to equal 0, 1/3, 1, or 4 over 3. If you expanded this out and tried to solve it without a substitution, it would be, it'd be a really horrible quartic equation. But through this substitution, we get a hidden quadratic. We just then need to deal with it after we've found out what u is, and that's what I've done here.